And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop. Now, you remember a couple of weeks ago I said this. And the other thing I noticed while I was editing away was a slight hum every now and again, just a sort of transformer hum, like ding, ding, every now and again. I thought, what's this as I'm working away? Well, of course, what happened was one side of my Thurlby Thandar power supply had blown its full bridge rectifier. And having repaired that, I thought nothing of it. But yesterday evening, I was editing the Pie Cow video, and sure enough, I can hear that power supply coming under load again. I glanced up at the Thurlby and it switched off, so it's not that. And what it turns out to be is my isolation transformer. So let's have a look at that. Okay, so here it is. You can see proudly on the top it says property of BT, British Telecom. These turned up at radio rallies and a few on eBay, etc. This one came from a radio rally. Obviously BT were getting rid of them. So yeah, and when it was a BT, does it say on it? I think it does. Hang on, let's just turn that round. So BT mains conditioning unit, model MC5A1000, input 230 volts 4 amps, output 230 volts 4 amps 50 hertz. Item code, serial number and all the rest of it. Inspection. Anyway, there we are. Oh, it's got a switch on the back. Never knew that. Couldn't remember that. We've got a fuse. We've got an earth binding post. And what these were sort of a big filter. They weren't isolated, in fact. You've got four 13 amp type outlets. Obviously, you're limited to 4 amps. And that was all you had on the original unit. I added the power display here, the circuit breaker and the on-off switch. I have to say I only had a 3-position switch at the time. I've never been happy with that. I ought to swap that when I take it apart, because I think I've got some simple on-off switches. So anyway, that's it. And here is the fault. So if I just plug it in, you'll see this display is very dim and not making a lot of sense. In fact, let's just switch that off at the rear. And what I want to do is just measure the output voltage. Where's my unsafe connector? Right, so let's just pop that in there. Connect a meter into it. Yeah, it did need some modification when these were bought to make them isolating. I think I wrote about it at the time in one of the ham radio mags here in the UK. Right, can you see that? Let's put it on there. So let me give that mains switch a go. Well, we are actually outputting the right voltage. So I wonder whether our failure is in this display unit that's just telling fibs now. But you can hear it ring every now and again. And yeah, that's not right. Okay, let's pull that plug again. And get the cover off. Ooh, let's see what we've got inside. It's very heavy, by the way. Yeah. As with all telecom stuff, it's well engineered. You know, it was designed to be on all the time. Well, it was probably sat in a, I don't know, telephone exchange, or maybe some larger clients where they were concerned about the quality of the incoming mains. Pretty much shot that one. I'll see if I can find a decent screw to go in there. And that's what's in here. An alleged 1,000 watt transformer. Yeah, what's a bit of a, I think, 1 AC limited. There it is. And it's just a 240 to 240, 1,000 watts, 1,000 VA, I should think, input and output. Don't This is not melted insulation. This is the varnish they used to insulate the transformer with. So when we had to modify it, oh, now that's interesting. Yeah, in fact, I did add the fuse holder in as well. Clever lad. Yeah, so what you had to do was the earth, you can see it's coupled up here, was actually still coupled to the front panel. So, yeah, that was still coupled to the front panel. So it did, in fact, not isolate you from earth, because it's also on this filter bank here. So, yeah. So what are we thinking? I'm thinking our little mains monitor module down here has failed. So we'll need to pop that out. It's not going to be so straightforward, because the neutral lead for the power supply obviously passes through the current transformer there, and that's quite a big terminal. Let's switch to a chunky bit and unsolder that from that capacitor. Capacitors are just forming a bit of a filter. Right, what I want to do, switch the iron on would be a good start. So I need to disconnect that one also. I suspect that little fuse is just powering the mains monitor. I obviously didn't trust it back then. Right, that's coming out. I need to ease the secondary back through the current transformer. Ooh, there it goes. So that's our problem, is with the mains monitor module. I wonder if it would be better to change it for one of the ones that I've got in the lamp limiter, actually, because that's quite good. Let's have a look at it anyway. Right, let's switch a bit of light on. Is that any better? What have we got? Okay, it comes in. We've got a little bridge rectifier. We've got some capacitors. Ooh. Something doesn't look very nice there. What's going on there? Just don't think it's very well made, maybe. There's a big high value resistor here, and I wonder if that is either... Oh, it's not, it's only 100 ohms. There's a 1 meg next to it. I'm wondering how they derive the low power to run, obviously, this microcontroller or A to D or whatever, and to drive the display. I wonder if it's a capacitive dropper or what. This would appear to unplug. No, it wouldn't. It is... No, it's not a plug, it's just a set of through pins. Well, those capacitors have been in there. I don't know when I did this. It was many, many years ago. Are they dated? Made in Hong Kong. This one's been hot where somebody soldered that previously. But you can guarantee... I don't think that was me. I think that was whoever manufactured it. Let us try and get it apart. I think I'm going to need to desolder these two connectors, one there and one there, and see if we can measure some of these capacitors and see if they're any good or not. Right, that's a plan. Okay, so here is our board. So mains is coming in, feeds the bridge rectifier. There's another diode there, feeds off to here. So yeah, I'm just going to check the health of these little capacitors there. Let's just undo these two wires here. Crumbs, they're really badly soldered on. 1, 2. I'm just going to stick a red and a black dot on there so I know which way around they were and where they go to. That one's red. That one's not. And I shall choose the peak meter. So it'll do these sort of things in circuit. So not that I think there's going to be the iota of charge left in these. I will just short them out. Okay, so here we go. This thing is, the transformer itself is generally left running. So you can understand it's done a lot of hours. 118.4 microfarads, 0.39 ohms. Hundred microfarads, I can buy that. 10 mic. So this one either can't be read or is leaky. So let's just slide that one out. Open circuit or low capacitance. He's failed. 47 microfarads at 16 volts. Let's see what we've got in the old box. 47 at 16. What have we got at 47? I bet it's going to be a big thing. 47s, yeah, they're huge. Still, I'm not exactly stuck for space, am I? There we go. What's this? This is 47 at 50. That's never going to go wrong. Nice Nichicon one as well. Super reliable stuff. Right. I must say, I was expecting to find something of this sort of current consumption, something like a dropper resistor in there that may have gone open, but not the case. Now, I didn't pay attention to when I took the capacitor out of its polarity. Thankfully, it's marked on the board. You see that in there. So there's one half that's shaded, and that's actually the negative half, as confirmed with another part. So can we sneak that in there? That's good. I need to clear these holes out where we desoldered the two pieces together. I'm going to check those around the current transformer as well while we're here. Ordinary sewing needle in a piece of chalk block. Where's the camera gone? There it is. Just so you've got a handle on it. Sewing needles are stainless steel, so the solder doesn't have a tendency to try and stick to them. So you can just line that up with the hole. I'll take those off so I can get my head out of the way. Stay stuck down. That's it. Heat it up with the iron. Push it through, and that'll just push all the solder out the other side of the board. And you can then desolder it with ease. There we go. Wait till it goes cold, give it a jiggle, and you'll see that's just pushed a nib of solder out the other side, so we can hoover that up in a second. Reassemble. Oh no, I was going to check these three caps down by the current transformer there. There's one there. Oh, nearly. Just test that again. .9 ohms, 4 microfarads. 2.9 ohms is large, isn't it? But they're only small capacitors, so they're not going to be super low ESR, are they? What's that one? 4.7, yep, there's no surprise there. I think these are that's a 4.7 and that's a 10. So let's carry on. They're all good. Have we been plagued by just one capacitor? Right. Snick the board back on top of the LCD. have a quick look at that. Right, I'm going to do something particularly dangerous now. I'm just going to hook this. Oh no, hang on. We haven't done our red and our blacks, have we? Let's just put those back down. Okay. Right, what I'm going to do is I'm going to snick these into the unsafe block and just see if it actually comes on and works without me having to reassemble the isolation transformer. What I am going to do is I'm going to drop it straight into the real mains. I have got a circuit breaker, what the Americans would call a ground fault breaker, what we call a residual current device in the UK. So if I do happen to come into contact with it, hopefully it won't do me any unpleasantries. Right, I think it goes that way up. I'm just going to put it. Oof. I'm just going to put it on a blob of blue tack. Obviously all of this is reference to mains as well, because it's running straight from raw mains. So here goes nothing. No, it's still talking utter rubbish. Okay. Right, got it apart again. We're going to take that capacitor out, which I think, by the look of it, is our capacitive dropper. So this is a capacitor whose value is chosen, so its reactance manages to drop the voltage in an almost wattless manner. The capacitor is under a lot of stress, and of course it leaves everything else reference to mains. It is 4/7 and 4 noughts in picofarads. I think we'll need the other meter for that, won't we? Oh. Get the old LCR right. Analysing 30.76, and we should have 47. You see that up there? You see it on that. 30.78. We are a little bit shy, aren't we? And we should have 47. 1, 2, 3, 4. Yeah, 47 nanofarads. Could that be it? Have I got 47 nanofarad? Looks be. That's the wrong box. It should be class Y, I think, shouldn't it? Really? Would be happier if it was. 47. That looks far too small. Let's just see if we've got the right value. If it's a high enough voltage, it may just do for a test. Right. Oh, I've got to put that back together now. Right, come back in a minute when I've done that.
2 hours later.
Right, I have done a few further investigations, and it turns out this board is innocent. Something on here has failed short circuit. Well, not short circuit, but is really, as soon as you connect this board up, yeah, there's less than 150 ohms between, there's a 5-volt pin over here and ground. This floats up a little bit higher than 5 volts. And yeah, as soon as it gets to here, that loads it down, and it all falls over and dies. So something has failed in the LCD module. I can't see me being able to repair that, so I'm afraid that is that, really. I'm going to want my bit of wire back out, or maybe not, I don't know why. But yeah, that is going over there. And we have ordered a replacement module from eBay, the same as I put in the dim bulb tester. I know it's probably overkill having two, because the dim bulb tester I always plug into this anyway, but it's just nice and reassuring that I have a display on the front of the unit. In the interim, I'm going to change that switch over for a single throw, and just tidy things up a little bit, maybe clean it, whilst that meter arrives from eBay. Okay, after a little wait for this to be delivered from a certain auction site, we've got the wiring type power monitor there. We've got that from eBay, and it's the same as the one I put in the lamp limiter, and without a shadow of a doubt, there it is. So we've got a current transformer there, and the monitor itself, so that needs to go in like that, and as suspected, the hole is going to be needed to be enlarged. So looks like I want to make it about there. What's needed is a Sharpie. Let's just have a little look at the instructions. Yeah, just operation instructions. We sort of know how that works. That's interesting. There's a 20 amp wiring instructions and 100 amp. Didn't realize that, so we needn't actually use the current transformer. Or is this for two different versions? This one is the 100 amp version. So 6 major functions, blah blah blah. Yeah, they're two different models. So okay, we do need to retain the current transformer. So we are going to need to make this a little bit larger. I think what we need there is a Sharpie and a fine end of my double-ended Sharpie, and we'll just mark around that and then enlarge the hole somewhat. Right, I think I'm going to just stand this on its end. And can I do that? Yeah, we got a stud and a lead. I think that'll be all right. Maybe not. Maybe what's needed is a VHS cassette. And this time we've got Deathstalker 2. Excellent. Right. Yeah, it's sagging all over the place, isn't it? Yeah, I'm not quite sure that's a fine idea, but hey, let's go with it. And if I line that up on the end of the holes, I will have less cutting to do. That looks about right. So I'll mark that out a bit. Doesn't exactly look level to me. There we go, that's better. Right, I think we know where we've got to cut to. Okay, just colour that bit in a bit. Right, that's the sort of kip of it. That's quite a lot of metal to remove. Right, let's get on with it. Hurrah. I think that's fitted. There are people all over the internet now screaming at me, telling me I've made an awful job of that. But actually, for my metalwork, that's not bad. Right, what I'm going to do before I continue, Brian PC, if you're still with us and you're watching this, I'm so sorry. Brian PC is the man who back in the 80s attempted to teach me machining and metalwork. Poor bloke. It's a bit tight in that top corner. But yeah, we're there. Next thing to do, I'm just going to tidy that corner up. And then I'm going to take it outside and give it a blow through with an airline. Important thing to do because we don't know what of this lovely conductive dust has got in with our electrical bits. Right. Okay, so it's actually the following day because things happened. I've blown all the swarf out, at least most of it. There's a bit there. There we go. Cleaned a few things up. There's our hole enlarged to take our energy monitor. As the usual standard of my metalwork is, it looks like I've cut it with my teeth. I've also stuck a hole here because I'm going to mount an LED on a bezel in there to indicate when the supply's on, because currently there's no indicator on it. And there's always been indicators on other things, but I'd like to incorporate that. And I'm going to show you how we can drive an LED off the mains, and it's going to involve a little bit of a lesson in capacitive reactance. Right, so that's going to go through there. I've attached 2 wires onto here to power the monitor. So I've got to get a neutral before the current transformer and a live, which I'm going to take from that fuse up there. Just hope this fits now. Yeah, look at that. Oh, it's a good fit. That is a good fit. Looks almost level as well. Oh, I'm pleased. I am pleased with that. Oh, go on. Just snap in. Oh, it's nearly there. That'll do us. It ain't coming out, that's for sure. Right, what I'm going to do is I'm going to mount the CT, the current transformer, up here. Except for I've already managed to tangle the wiring up. There we go. I'm going to mount the current transformer. I'm just going to super glue that to the front panel there, and the neutral wire can go through there and measure our current after the switch. So that's good. Interestingly, I've noticed there's an arrow on the transformer, on the current transformer, which would indicate direction, but that makes no sense because we're measuring AC, which is a bit odd, really. Right. Apparently, pay attention to the direction of the mutual inductor. It should face the load. So that is the load. So we'll be coming in that way. And it does show it on the diagram as being in the neutral. So that's how it's going to go. Right, let's bond that in place. Okay, we're going to want to clean everything, get all the grease and gunge off it. We'll have some IPA for that task. I tell you why it probably wants to face the load. It's looking for a signal in one direction to be able to calculate the power factor or something. I don't know. Yeah, right. Okay. We will have a little dab of the black super glue. So this wants to face the load, and of course the phone rings. Right, rudely interrupted by the telephone. Smear of that on there. This is the black stuff that RS do. And I find it to be a lot better than your ordinary super glue. It's worth the extra money, perhaps. Right, I want the arrow pointing towards me. And there we go. Let's just hold that in place and wait for the stuff to set. Right, well, while that's drying there, I'm going to put the wiring in. I've just realised that this capacitor is not actually connected on both poles anymore, and hasn't been for years. So I think what I'm going to do is I'm just going to remove it. I'm going to take that off there, make the neutral onto here now, and go with that, I think. So no point in it being there. No point in it existing, is there? There we go. Extra air hole. Excellent. Right, so I want the neutral of my energy monitor going back to there for power. The live is going to go up there to the fuse. Okay, so perfect. Right, there at last. So, quick sanity check. We've got live and neutral from the instrument fuse there, feeding the monitor, energy monitor itself. We've yet to connect the CT, so that has got a point, so that's towards the load there, so yep, that's round the right way. That then feeds through the current transformer to measure our current, and that is fed from this one here. So I'm going to make a join there. We shall get a lot of heat shrink on there. So let's just have a little go at that. There we go. Right, well, it should now work. So, moment of truth, nothing's happening. Excellent. There we go. 240 volts, 50 hertz. That's working beautifully. Now, let's put a bit of a load on there. Let's go find something to be a load, shall we? Right, I've just got a lamp connected. So there we go. No watts. Interesting. But, well, current is working. 42 milliamps, which I reckon is right. Power factor of 0.98, which would be about right. No. I tell you why. That doesn't work on the other unit either, does it? It just switches the backlight on and off. Yeah, I had this before. The watts don't function. It doesn't function on the other unit. But, you know, these things are only about £8. It's giving me all the data I want. Anyway, it's got 239 volts, 420 milliamps. 50 hertz is irrelevant. It's going to be somewhere near. But yeah, there we go. Right. Okay, right. So everything's working there. It's good. Now we're going to need to make our LED indicator. And for that, I'm going to want a 100 nanofarad class X 2-type safety capacitor. I've got a bridge rectifier here. This one is it's a W08MG, which is 800 volts, 1.5 amps. It's the one I actually use in the Lin record players every now and again. We're going to want an LED. I've chosen red. Your colour preference may vary. And we're going to want a resistor about 1000 ohms. And here's what we're going to do. So we've got the output from our transformer. So for the sake, despite the fact it's not really live or neutral, we're going to have live and neutral there. We're going to come across here. First thing we're going to do is put our 100 nanofarad capacitor there. Now, because this is being fed from a transformer, I've got a dirty great big coil of wire here. I'm going to leave out a part that we would normally include, and that is a high value resistor across that capacitor, just there, say at 1 meg, something like that. And that is to stop, you know, when you disconnect your supply from the capacitor discharging, and your live could get a bit zappy. It's only 100 nanofarads, but let's avoid that. Because I've fed this from a transformer, it will actually discharge straight into the transformer, so not got a problem with that. So I shall be leaving that out. Then we're going to feed our 1000 ohm resistor. Then we're going to feed our bridge rec. So these are the AC terminals, top and bottom. And then we've got plus and minus. And we're just going to stick our LED straight across there. No current limiting, because that's taken care of up here. That is 1K. Right, now, what's going on here? 100 nanofarads. Now, a capacitor, when it's looking at AC, it behaves like a resistor. And 100 nanofarads at 50 hertz looks to be, I think it's about 60K, isn't it? Let me just do that calculation. There are online calculators we can use. So we're just going to want to know its XC calculator. I'm going to pick the first one, capacitive reactance calculator. So we've got 100 nanofarads. We've got 50 hertz. That's 31K. I was right. It's about 31 kiloohms. So that's going to limit our current into there. And yeah, the reason I'm using a bridge rectifier, by the way, is so the LED doesn't flicker. You can just put the LED in there, but it's not very well protected. You need to put some reverse polarity protection in there, or your LED won't last 2 minutes. Right, that's what we're making. Let's make it so. There it is. Looks perfect for the job. Right, I've got the indicator mounted up on the back of the front panel there. I've super glued it in so it can't move about. Yeah, so the unit is plugged into the mains, but the output's not on. So moment of truth. Oh, yeah, there's no mistaking that. That's on now. So yeah, pleased with that. Let's turn the workshop lights down a bit. There, you can really see that on the camera. Yeah, you can. That's a super job, and it's not flickering appreciably. So that makes me happy. Lovely. I'm calling this fit. Put the lid back on, put it back into its rightful place, which is over on the far right of the bench, and let's do some proper repairs. As always, thanks for watching. Click like, subscribe, do all that rubbish, and come back really soon here to Doz's Television Workshop. Cheers, bye. Doesn't look to have made any difference whatsoever, but there we are. Excellent. I'm pronouncing that fit. Let's just do this section again.